So look at number 3 when you get to them. Alright, to review from yesterday, if there's a number with the x, is it moving it left or right or up or down? If this 2 is grouped with the x, left to right, and if it's positive 2, it moves it to the left, because x is a joker. If it's negative, it moves it to the right. If it's on the outside, it moves it up and down. If it's negative, it moves it down. Alright, we already graphed these. I just wanted to go over the domain and range. The domain is going to be what here? What is it? How far left is this going to go? Thank you. To what? Infinity. And then the range approaches what's the lowest value?
1.
0. Goes past 1, lower than 1. Does it touch 0? So we have to put a parentheses. It goes to infinity. Hadn't all the ranges been like that and all the domains? Yes, except for this next one. Does the range of the domain change? No. The domain, of course, is going to stay the same. This time it's approaching what? Negative 3. Good. And goes to what? So really, to tell the range without even graphing it, if you look at this number is always going to be what your range is, right? That's why on the other ones, was there any number being added or subtracted to the function here? Nope, so it's always going to be 0. Everybody see that? So like for this next one, let's find the domain and range first without graphing it. What's the domain going to be? Infinity. What's the range going to be? Go ahead. 0 to what? Good. So you can find domain and range without even graphing it. But now we are going to graph it. Okay?
Wouldn't it reflect since it's negative?
Correct. Let's figure out what axis it reflects over. We're going to use the same x values. Do I need to go over how to find the y values, or are y'all good with that? Then go ahead and find all your y values. I don't have another one. You can use your phone. Oh, I have a crappy one. And make sure you leave these as decimals instead of fractions, so that way they'll be easier to graph. Everybody done finding those values? Katie, what'd you get from negative 2? Did everybody get that? Amber, what'd you get for negative 1? Alright, Victor, what'd you get for 0?
Negative 1.
Good. Colby, what'd you get for 1? And Logan, what'd you get for 2?
16? Or negative 16?
Yes. Alright, go ahead and graph the points you can graph. Oops.
Why didn't you get for negative 2?
Alright, what'd you plug in your calculator? Alright, we're going to have to go back and change our range on this one, as you can see. But let's talk about what's different about this equation than the one right here. It flipped it across which axis? X or Y? X axis, good. So it flips across X axis when the negative is out front, just like that. So all that does with our range is going to flip what? What's the highest point? 0. So it's going to go over here. What's the lowest point? Negative infinity. Good. So it does change if there's a negative out front. What do you think would happen if I gave you one like this, like 4 to the negative x? Do you think it would flip it?
No.
Yes, but across which axis? The y-axis. Good. Any questions? Flip it over. And this just kind of reviews what we were talking about, the translations. Like if it's with x, it's moving left to right. If it's on the outside, it's moving up and down. And then the a, if it's negative, it flips across the x-axis. So pretty much everything we've already talked about kind of summarized up here. Okay. What I want you to do first is graph this 2 to the x by making a table. Go ahead and do that part on your own. Find your values, then graph it on your own. Don't graph this one yet. We'll do this together. Just 2 to the x right now. You don't even need your calculator to find these y values. Alright, we can get through these pretty quickly. Antonio, what'd you get for the negative 2, the y value?
2.5.
Good. Kelsey, the next one?
45.
Miles, next one? What's the y value for 0?
1.
Okay, Darian, next one?
2.
And Camden.
4.
Alright, and then the graph should look like this. And now we're going to graph this other one, not by making a table, but just by using translations. Okay, so this 2 is going to move it left to right. To the right, very good. The 1 is going to move it what? The 1 is going to move it up. So just take each point that you just drew and move it 2 to the right, 1, 2, and then 1 up. And draw another dot. This one, move it 2 to the right, 1 up. This one, move it 2 to the right, 1 up, all of the dots. And then go ahead and draw your function. Oops. So none of the points change, just move in directions, that's all. Questions about that? And then this part was describing. So like on the next test you don't have to write out full sentences, just say this moves it 2 right, this moves it 1 up, and then use it to graph it. Alright, now I want you to take a minute to do A and B on your own. I want you to circle which one of these graphs represents this, and then kind of explain how you knew that. Okay? Just circle the one that is this function. and then write out to the side how you do that. Same thing with B. And then we'll discuss which one it is and how we do that. Try not to use your graphing calculator, don't cheat. Nope. You don't need it. Alright, notice this one has like a -4. This one has -3. And we didn't make that. But see how it's approaching -3 right here? This one is approaching this value. Which one is approaching -4 here? Okay. Do the next one. Anybody have an answer for A? Or for the first one? Did y'all pick A, B, C, or D? Alright, tell me why you picked C, Colby. I just heard you first.
I plugged it in and I plugged -2 in and for 2, plugged in -2 for X. And so I got 0.25.
Okay.
And you subtract this one, so it's -3.75.
Gotcha. And you just looked at this where the Y value was? That's a good idea. So plugging in a point, what'd you do, Kelsey?
I saw that it had -4 in it, and in graph C it was approaching -4.
Perfect. So the range has to do with this number, right? So see how the graph here is approaching that -4, your Y value? No other graph is. So that's the way I saw it. Very good. Anybody do it a different way? Okay. Any questions about that? So just write, how did you know that? Colby could say, I plugged in a number to get the Y value. Kelsey could say, looked at the range. That's what I did. Looked at range, approached -4. Go ahead and look at B. Decide which graph is best. And which one did y'all pick? A, why? Plugged it in again. And you could also look at the what? The range. This is the only one that is approaching 3. This one's approaching what Y value? Just so we're clear. 4. This one's approaching. This one's approaching. Everybody see that? That this is the right answer? Any questions? Okay. That is all for chapter 4.1 part 1. And most of these graphs that we drew were what? Increasing or decreasing? Increasing. So what these are called are growth functions, exponential growth functions, because they're growing. Well, now we're going to look at decreasing, which is called decaying functions, okay? If you didn't get your copy, it's up at the front. And I might need a copy myself. No, I got it. Yes? I don't want you to miss the notes. You can go after we finish. Alright, next one, same thing. We're just going to fill out some X and Y values, -2, -1, 0, 1, 2. You already know how to find the Y value, so I want you to go ahead and do that. Make sure when you're plugging these in the calculator, you plug it in just like this. Parentheses 1/5 to the -2 power and so on. And then also do number 2. And what I'm going to do is I'm going to pick 2 people's paper and show it underneath as examples. So go ahead and do the first 2. Make sure you write the domain and range.
one. I use decimals there.
That's fine. Alright, here is one of them. And let's look at this one. He didn't use decimals, but that's okay. Did the first one y'all get, is that a 25? Did y'all get 25 for the first one?
Yeah.
Next one should be 5, next one should be 1. This as a decimal is what? And this one? 0 point what? Good. Make sure it's 0.4. And then when you graph it, it should look like this. Notice it's decreasing. That's why it's called decay. What do you think determines that, whether it's decreasing or increasing? If it's a fraction or not. Good. So this one's a fraction. The base is. That's why it is decreasing. And then the range, is this correct? Does it go left forever and right forever? Is the lowest point approaching 0? Yes, and goes to infinity. Very good. Alright, let's look at this next one. Make sure your y values are correct. Is 4 the right answer? Then 2, then 1, then 0.5, then 0.25. So this is how it should look, still decreasing. And the range, does it change any right here? The domain range? Nope, because there's nothing being what? Added or subtracted. It's not being reflected. So we're good. Any questions about those two? They're the same, 0 to infinity. Alright, flip it over. We're not going to do all of these because I think y'all got the hang of graphing it, right? I don't have to do a lot more of these. This first one corresponds with number 2. Okay? It's a transformation. Let's talk about, first of all, what does that 1 do? It moves it to the what?
Left.
X is a joker, it moves it to the what? To the right. And the 2 moves it what? Up. Good. I want you to graph this one either by regraphing number 2 on here and just moving the points, or you can make your table. Okay, so I want you to decide how to graph it, number 3. And then if we get this one good, we can just go ahead and move on to something new instead of keeping on graphing. So let's set make the table. That would be easier. This one. Can I write this? Oh, it's not that. I'm done. Okay. Let me write this over here then. Alright, I want you to put your pencil at this point. It's negative 2,4. Just put your pencil where it is on this. Don't actually graph it. Good. Now move your pencil 1 to the right, 2 up. Draw a dot. That's it. Do it for the next one. Put your pencil there. And then go right 1. That's 2. Draw a dot. Do it for the other 3. That's the easiest way. Make sure you put the domain and range on this. And then I'm going to grab some paper. Transformations.
So we should have 2 different graphs.
You don't have to. Like I was showing Jalen, you can take the points. I'll show you.
From that.
Like I knew from the table here, negative 2,4 was my first one, right? Negative 2,4. So I could put my pencil on negative 2,4. And then, oh wait, negative 2,4. And then just move right 1 up 2. You don't have to actually graph it. But this is how yours should look in the end. Did anybody do a table instead of transformations? Okay, does yours look like this? Okay, keep working. I'll give you time. I'll give you time to finish graphing. I would use transformations though. It's easier. Notice how the range and this +2 match up. Everybody see that? The range, the lowest point's approaching 2, which is correct, and it goes to infinity. The domain, of course, doesn't change, but the range approaches whatever this number is right here. Did everybody notice that? Alright, so we won't graph this next one, but what I want you to do is I want you to just tell me, well, we can't do it because it's reflecting. Let me see. B. I want you to circle which one is correct and then tell me how you knew that. So this is on the back here. You're welcome. Circle which one's correct, and then write out to the side how you know it's correct. We're on the back of this, working on this problem, the multiple choice one. B. Just circle which graph is correct, and then write out to the side how you know it's correct. So circle either A, B, C, or D, which one matches up here, and tell me why you think that's correct. Okay, very good. And what'd you put? Okay. So this one, look back at the range.
Miss Horton?
Yes.
Hey, did Camden Marshall make it in?
She did. She had a pass.
Thank you.
Okay. See how this range approaches to because it's this number? Okay, so look back at this one. First of all, there's a negative out front, so you know it's going to be reflected, right? So it can't be which 2. Yes. Okay, and now which one's approaching -3 out of these 2? Very good. Alright, how many put A? Circled A. B? C?
Miss Horton?
Yes.
What about Lincoln Modern?
He was just tardy.
Gotcha, thank you.
You're welcome. Alright, who picked A again? Raise your hand. Alright, Victor, tell me why you picked that one.
Because it approaches -3.
Alright, what else? So this, he used this, said the range was approaching -3.
And also, the x1 is 2 means it's transforming to the right too as well.
Is that correct? The 2 moves it to the right? Yes, 2 to the right. What else? One more thing.
That's also flipped over the x-axis.
Perfect. That negative flips it across the x-axis. And let's just make sure this graph matches up. We know it's flipped. Okay? Is it approaching -3? Yes, that y value is approaching -3. And it is moved 2 to the what? Right. So this one's correct. Why couldn't it be B?
It goes over -3.
Yes, it touches -3. We know there's an asymptote there, so it can't touch -3. Okay? Why couldn't it be C?
It's not flipped. And it goes over.
Good. It's not flipped and it's touching -3. What about this one? Same thing. Okay? Yes.
I got confused at first between B and A, and so I started plugging like the X values in, and I was getting like
Crazy numbers. Let's try it. Which one did you plug in?
I tried -2, and then I tried -1 and I tried 0.
Yeah, and that, like, -2.
I was getting like -400.
Good. Because you notice on these two, you picked like negative numbers, right? And if it is picking negative numbers, this is going to go down forever. That's why they're so low. Does that make sense? Yes, you should have picked. If you knew it was these two, you said you got confused, I would pick one that actually shows where the graph is.
Okay.
Because you should get crazy numbers on these because it's going to go down forever. At -2, it should be like -400. So they're not crazy. They're accurate. Any other questions? Alright, now we're going to tie this into kind of some real life stuff. And this is important for y'all because talking about money, I know y'all will be interested in money. Can I get somebody to read that first sentence? Go ahead, Antonio.
The old equation P equals R2, surface equals rate times time. Suppose this formula in the real world, you should be all right.
Okay, so this is talking about kind of your bank, your money, okay? So if you were to put a deposit in the bank, the principal is how much you put in. The rate is like how much it's compounded, like 3%, 2%. And this is time. Okay, but what it doesn't take into effect is compound interest. Write that in here. Compound interest. Interest. Which is interest computed on your original investment plus any accumulated interest. So the sum of money that you put in is called principal. So anytime you see P, that's what it's talking about, the initial amount, principal. And it's invested at an annual percentage rate, and the rate stands for, or the R stands for rate. In decimal form, it's compounded once per year. Because the interest is added to the principal at year's end, the accumulated value is this formula, which looks really messy. But if you take out a P right here, because they both have P in common, you'll get 1 plus R. So here is over T years the formula for compound interest. And we're going to use that in a minute. Now some banks don't compound like each year. They do it in different periods, like annually, monthly, quarterly, weekly, and biweekly. Let's jump down to that for a second. What is annually talking about? Yearly. Okay, so if it compounds annually, they compound once per year. Monthly, there's how many months in a year? So if they compound monthly, it'd be 12 times per year. What about quarterly? 4. Good. How'd you know that? Who said that? Who said that? Okay, how'd you know 4?
Well, there's 4 seasons, and then there's like 4, 12 kinds.
Very good. So it's talking about seasons, pretty much 4 seasons in a year. What about weekly? How many weeks in a year?
52.
Good. Okay, now let's talk about bi-weekly. Bi means what? Every 2 weeks. So if we divide that, 52 by 2, we'll get 26. Good. So if it says it's compounded bi-weekly, that's 26 times per year. Weekly is 52. Quarterly is 4 times a year. Monthly is 12. Now some banks, and sorry, that's in compounding periods per year. So anytime you see in, that's what it's talking about. These numbers we just talked about. Now some banks compound continuously. Compounding continuously. I hope I spelled that right. Where the number of compounding periods increases infinitely. So like they would compound every trillionth of a second or quadrillionth of a second, which sounds good, but they mess you up on the rates. You'll see that in a minute. It's not always a good thing. So we're about to discuss like if it's better to be compounding continuously or compounding annually, monthly, weekly, quarterly, based on the rates. All right, flip it over. I'm going to write I put this up here so you wouldn't have to keep flipping back for formulas. For compounding n times per year, this is the formula, so you won't have to keep flipping back. 1 plus r over n to the t. And then for continuous, that's going to be p to the ERT. E's on your calculator. Alright, Darian, if you'll read under
What is it?
What's that?
It's like an F word.
this one,
No.
this is n, n to the t,
R
r over n. Sorry,
I thought that was all over H.
no, r over n. Before we start this, the P stands for principal. That's like the money you're putting in. So over how much you're putting in the bank. The R is the rate. The N is like how much it's being compounded, like if it's monthly, quarterly. The T is time in years.
What about A? That's annually.
A is how much you'll get like after this compounding is over. Okay? And then same thing here, principal, rate, time. Alright, now will you read this one? Gary.
You decide to invest $8,000 for 6 years and you have a choice of
between two accounts. The first account pays 7% per year, compounded monthly. The second pays 6.85% per year, compounded continuously, which is the better investment.
So you're trying to figure out how much money you'll make, like the most money, whether it's compounded monthly at 7% or continuously at 6.85%. Any guesses before we get started?
7%.
The 7% one? All right, let's see. All right, first let's identify what that 800 or 8,000 is. That's your what? P, R, N, or T?
P.
P. What is our T?
P.
6. Good. Time in years. This first one, the rate is 7%, but we need to change that to a decimal. Anybody know what that's going to be? Good. And then compounded monthly, so N will be perfect. Let's go ahead and figure out what that one is first. So this is where we use the compounding N times per year formula. So this will be A equals P, which is 8,000 times 1 plus, go ahead, 0.07 over 12 to the,
12 times 6.
good. All right, let's take care of what's in parentheses first, leaving the 8,000 alone. What is 1 plus 0.07 divided by 12? Say it one more time. 0.058. Okay, let me make sure on that. Go ahead and raise that to the 12 times 6 power. I got for this part 1.008.
Yeah, we have the one.
Oh, okay. Gotcha. So in parentheses, it should be 1.0058. Good. Raised to the what's 12 times 6? 70. Good. So raise 1.0058 to the 72nd power. And you should get what? Yes. Let's round that to 1.52. So what is going to be our total amount after 6 years?
12,000.
Good.
84 cents.
And 84 cents. Perfect. So that means you started by putting 8,000 in. After 6 years, compounding at that, you'll have this much. That's if you don't take any out. Okay? So that's a good game. Let's find out what would be if we did it continuously, okay? The rate for continuously they gave us was 6.85, so as a decimal it would be 0.0685. So this would be P e to the RT. We plug in 8,000 for P. E to the RT would be 0.0685 times same T would be 6. Does everybody know where the E button is on their calculator and how to use it? Okay, we will start on this then tomorrow. So we only have 2 problems left. Don't forget about your test if you haven't finished it. Almost got done with it. Yeah.
I got turned in the wrong math work question today. So I found this one the other day.
Okay, I'll take it.
10:30.
And did anybody take a yellow calculator home and forget it? Okay, just make sure. Make sure you don't take these.